Hello guys, welcome you all for this end-to-end session of AIML where you guys gonna learn everything that you guys need in order to become a successful data scientist. Hope you guys are enjoying. We are enjoying a lot and we are learning a lot and we are improving our knowledge. Hope the same thing for you guys. So today's session is all about the continuation of evaluation metrics. So please make sure that you guys watched all the previous sessions so that you can have a better understanding of what we are talking. Okay. So the thing is today, as I mentioned, it's a continuation of like evaluation metrics. Okay. So guys, as always I am telling, right, make sure you guys watch all the previous session videos so that you can have a better understanding of what we are telling you. Okay. So the thing that we're gonna see today, as I mentioning earlier, like it's a continuation of previous session where we are teach you how a evaluation metrics can be applied onto a classification model, regression model, and what is confusion matrix. These things we have explained. Okay, let's see what we are having today. This is also evaluation metrics, which is very dedicated to classification and regression. Okay, let's see this ROC curve and AU curve, AUC curve. So the receiver operating characteristic, that is ROC curve, plots the true positive rate against the false positive rate for different classification thresholds. Guys, this is the reason I'm just asked you to look into the previous session, because like where we have explained this true positive and then false positive. Okay, true positive means it's a positive prediction which is done correctly, whereas false positive means it's a positive prediction which is done falsely. Okay, so that ratio is done by using this curve graph called as a receiver operating characteristic graph, that is curve, whereas the AUC, that is area under curve graph, which represent the model's overall performance, indicating the ability to distinguish between different classes that we are having. Okay, hope you guys can understand, right? ROC curve, it's used to find the something like a relationship kind of thing between the true positive and then false positive, whereas this ROC curve is used to provide a like how well our model is there to distinguish different classes. Okay, hope you guys can understand, right? Yeah, moving on, let's see the parameters, the simple things. First is true positive rate and false positive rate, which both are very important for this receiver operating characteristic, that is ROC curve. So true positive rate, proportion of correctly identified positive instances, that's it. Like I have an example, right? Always I am saying this example only, right? The person have a heart disease or not. The positive case here is the person doesn't have a heart disease. So that is what the proportion of correctly identified positive instances. Okay, the person doesn't have a heart disease, which is predicted by our model correctly. False positive rate, the proportion of incorrectly identified positive instances among all actual negative instances. Among actual negative instances. Okay, it is predicting that the person doesn't have a heart disease, but actually the person have a heart disease. That is what this false positive rate. Okay, next AUC curve, it's simple. The area under curve, which is the ROC curve. So the area under the ROC curve, okay, representing the overall performance of the model. Okay, we will be having a ROC curve. Under that we will be having the area under curve. We have a curve inside which we are having a area under curve. Okay, you can see, right? This is the ROC curve. Okay, like receiver operating curve, under which we are having some area, that is called as area under curve. This represents the performance of our model, which is able to distinguish the number of classes that we are having. For example, the person have a heart disease, the person doesn't have a heart disease. This is what the classes that we are having here. Okay, hope you guys can able to understand. So this is what the ROC curve and AUC curve. I will say this is one way of approaching this classification problem. So where we have previously we had a different kinds of values, right? Like accuracy is a one way of metrics, precision, recall, F1 score, like that we are having ROC curve and then AUC curve. Okay, hope you guys can understand. Yes sir, over to you.
Yeah, guys, ROC curve and AUC. Okay, so what is first of all ROC? ROC is the receiver operating characteristics. So whatever the receiver operating character the receiver's operating characteristics, that's what ROC means. It's a curve plot that the true positive rate against the false positive. So whatever is true positive means right against the false positive, whatever is not right. This is how you can differentiate. Okay. Rate for different classification thresholds. That is what it is. And then second part of it, the area under the curve AUC. That is ROC, and this is what is AOC. AOC is area under the curve. Okay, you can see that it represents the model's overall performance, indicating its ability to distinguish between classes. That's what it. Area under the curve represents the model's performance, indicating ability to distinguish between the classes. That's what it will do. Okay. So hope you understand what is ROC. ROC is receiving operating characteristics, which is positive rate against the false positive rate and for different classification threshold. And then AUC is area under the curve. Simple. Represents the model's overall performance, indicating the ability to distinguish between classes, different classes. Okay. And then the components of it is true positive rate, TPR, the portion of correctly identified positive instances. Like whatever was true, whatever was positive, it correctly identified that. That is what is called true positive rate, TPR. Okay. Then what is FPR? It is the portion of incorrectly identified positive instances among actual negative. So what it has done is actually the data was false, negative. Actually it was negative, but it has identified as a positive instance against the negative. So that is why it is false, false positive. See, it is positive, but it is false positive because it's not actually they were negative. That's why it is false positive. Actually, something is negative. I gave example. Somebody sees elephant first time, say somebody will say, oh, this elephant has teeth. These are the teeth. So somebody might imagine, oh, these are the actual teeth. Elephant eats food, right? But is that true positive? No, that is false positive because actual teeth are inside the mouth. So that is what is called false positive rate, FPR. Then what is AUC, which we already discussed? Area under the curve. Whatever is the area under the curve, you will have data. It can be millions of data, it can be billions, trillions of data. So your curve would be according to that, right? How much is the data? So spread. Okay. So the spread, how much is the spread? But in the curve, how much is the area under the curve? Whatever data curve is there, and under the curve representing overall performance of the model. That is what is AUC, guys. Whatever is in the area under the curve representing overall performance. That's it. You need to objectively think here. Okay. So it's not that any data, it is overall performance of the model under the curve. That is AUC. That's it. Under the curve, area under the curve representing overall performance of the model. That is what is AUC. Absorb it, digest it, and apply it. Okay. So I have made it very simple, guys, because simplicity is about genius. Somebody is genius, okay? So Einstein said, above genius, there is a level called simplicity. So when you make things simple, you are above genius. So make things simple, have simplicity in your life, have simplicity in learning, you will be successful. And let's move to the other section.
Sure, sir. Yeah. Let's see what we are having. Yeah, bias on various trade-off. I hope like you guys already know about these topics, So that's the reason I'm just asking you guys just go through the previous session so that you can have a better understanding of what we're gonna talk today. Okay, this bias and variance I think nearly like 3 to 4 times myself and sir has explained. Okay, let's see what we are having in these slides. Okay, bias and variance trade-off. So bias and variance trade-off is a fundamental concept in machine learning. Yeah, high bias model or underfit model. That is, the model doesn't work for the test data and train data and tend to make consistent errors. While high variance model or overfit model, that is, the model memorized all the training data so that it is not able to work for the test data and perform poorly on the unseen data. Perfect. The goal is to find a balance between the bias and variance for the optimal model performance. Guys, I hope you guys doesn't need any explanation for it. Okay, because if you have a high bias model, it's underfitted. High variance model, it's overfitted. We need to have an optimal model. Okay. High bias, underfit model, unable to capture complex patterns in the data. That is, underfit model means the model doesn't work for the training data itself. So how it can work for the test data? High variance, overfit models, sensitive to noise and performs poorly on unseen data. It memorizes everything in the training data so that it is not able to generalize on the test data. That's it. Okay, that is what high variance. Okay, hope you guys can able to understand because it's like I think it's the fifth time that we are explaining. I'm just like I'm myself explaining this bias and variance concept of trade-off. Now, sir is gonna explain again. Yes, sir. Over to you.
See, guys, why we are learning this, guys? I'll tell you a fundamental reason. Human beings by nature are biased. They are always biased. We want to optimize. I'm not saying I'm also like sometimes we are biased towards decisions, right? So that is why we should not be biased. We should be, I think, optimally balanced. We should not be biased towards one side, the other side. We need to be very neutral and middle path. Okay. So bias variance trade-off. See, whatever limitations human beings have, we have developed concepts and models and principles and equations for that, guys. Whatever abilities we already have, we want to enhance them. That is why we have built all these technologies. So everything comes from humans, human behavior, guys. Okay. So the bias variance trade-off is a fundamental concept of machine learning. High bias models are underfit. Why underfit? They will not learn. They will learn so much that um they are biased towards one particular thing, na? So they'll not learn according to the balance way. That is what generalization they will not do properly. Okay, and the trade to make trend tend to make sorry underfit and tend to make consistent errors because see if you make something biased it is going to give results according to that. So it is not going to learn realistic, real life, and application of particular whatever real life problems are. It is not going to solve that. Then there is no need to build such models. If you want to build bias models, then I think you should not build and no, don't waste time building such. And you have to be very clear when you're going collecting data from the right source, ethics, integrity, right characteristics, right model, all those things matter. So then you'll not have these things. And the while the high variance models are overfit, so this is a great example of underfit and overfit, guys. Understand this very, very pro. If you understand this, this is I'll say this is the soul of your model, guys. If you understand this, you will have always better. You have to work on other aspects, but at least you will have better performing models. Okay. So while the high variance models are overfit and perform poorly on unseen data. Okay. So one end, if model is underfit, it is going to make errors, guys. The output would be it will make errors on the realistic application, whatever your model building for. And if there is high variance, which is overfit, model will perform poorly on unseen data. And that is what you want model to perform on unseen data because it is overfit. Okay, so overfit is that it has learned so much that it is not going to learn from unseen data. It says, oh, I don't want to spend time on this. I've learned much. I am very good. I am intelligent. Like you have an intelligent student in the class, I don't want to learn something new. I am intelligent. I get 99%. So why he will? Bottle is already filled, so it will not learn. So that is why overfit. Huh? The goal is to find balance between bias and variance. These are two important keywords, guys. Remember them, bias and variance. Bias, if data is biased, model will be underfit. If there is a variance in the data, it will be overfit. Just remember these two things. Bias is under, variance is overfit. So again, here is a confusion matrix because you will get confused. Oh, what is underfit? What is overfit? So underfit is when it is biased. Variance in data, when there is high variance in data, that means it is overfit. And optimal model is the actual model which we require to get best performance. Okay. So high bias, underfit model, unable to capture complex patterns in the data, which is like it will make errors. That would be the output. This is the behavior. It will not capture complex patterns in the data. Again, in variance also, it is not going to learn from the unseen data, which is again that it has to learn from the unseen data or patterns, but it is not doing overfit. Both, if you see, both things are same, but in terms of academics, you need to make statement clear. Otherwise, interviewer will say, oh, he doesn't know, or uh, professionals or people will say, oh, he's not knowing. He's a data scientist. He is AI ML engineer and all researcher. He's not knowing this. So ultimately, if you see, the both are not going to learn from the unseen data or the patterns or the data. That is the main thing. But in terms of academics, you have to tell people, oh, the underfit means that it is biased, it is going to make errors, and it is not going to capture the patterns. And high variance also, overfit, sensitive to noise, performs poorly on unseen on both. If you see, they have their own problems. Noise, it captures the noisy data, which is like outliers, not relevant, and then it will not learn from the unseen data. And then here, if you see high bias, it is not going to capture the complex patterns in the data, which is again unseen data. Ultimately, what we are doing, so machine learning models are going to capture the patterns, guys. For us, we are saying data, unseen data, and all. Actually, it is the patterns. It learns from the patterns. If X is here, Y is here, then where is Z? So it's like if Z is here, Y is here, X is here, where is X? If Z is here, Y is here, X is here, where is X? Where is Y? Where is Z? So this is how it will look for patterns, your model, because it is not having consciousness. So it will learn from the model patterns. Ultimately, patterns are the main thing in machine learning models which it learns from the patterns. If they find patterns, like you have a spam, so these are the patterns. Text is the pattern for there. Okay, somewhere in cancer 0 and 1, if you have these patterns, somebody has a cancer. If somebody has this disease, it might not have. It will always predict, and probability based patterns it will give output. So make it very clear. I will reiterate again. High bias is when data. High bias means underfit model, unable to capture the complex patterns in the data. Okay. Overfit model, sensitive to noise and performs poorly on unseen data. High variance. High variance is overfit. High bias is underfit. Okay. But the behavior would be same. it is not learning from the data or the patterns. That's it. So we made it very simple today, that so that all confusion goes away, because simplicity uh, is the best intelligence, you'll say, a conscious intelligence. Next to, like, highest level of intelligence, genius. After genius, there's simplicity. So keep things simple, you'll be successful. Keep learning deeply.
Yeah, let's move on. Okay, like we have a better understanding of what is this bias and variance trade-off. Yeah, let's move on. Okay, cross validation techniques. Okay, let's see what it is. Cross validation are used to access model performance on the unseen data and reduce the risk of overfitting. K K-fold cross validation divides the data into K-folds and iterate through each fold for training and testing, averaging a result for a more robust evaluation. Yeah, cross validation means if you are having 100 data, right? First 10 data is for testing, other data for training. Last 10 data for testing, other data for training. Middle 10 data is for testing, other data for training. Like that, you will go for different kind of validation splits and you will train your model. So now the model doesn't underfit, doesn't overfit, and you will get an optimal model. This is one of the way of getting an optimal model. Data split, divide the data into k folds, whatever fold, 3-fold, 4-fold, 5-fold, anything that we need to mention. Iterative training, train the model on k minus 1 fold and test on the remaining k fold. Okay, so if you are having k fold, like 4 folds, 3-fold for training, 1-fold for testing, like that you need to keep on iterating and training. Performance evaluation, average the performance metrics across all k iterations for the reliable evaluation. So you need to get the accuracy of all the k folds, and you need to average the accuracy. That's how you can get the accuracy of the entire model. So I will say this k fold is one of a way to get an optimal model. We have seen lots of things, right? This one makes your model optimal. Okay, I'm pretty sure, because you're gonna train your model with different kind of splits. So what happens is now your model is able to learn everything rather than of memorizing, and it is used to generalize the things. Now your model is able to predict on the unseen data very clearly. This is what cross validation method, that is k-fold cross validation method. So hope you guys can understand. Yes sir, over to you.
Yeah, cross validation techniques, guys. They're very, very important techniques, guys. So let's understand. Cross validation techniques are used to assess the model's performance. That is the main characteristics, okay, on unseen data. Reduces the risk of overfitting. So we've learned bias, which is like it will make errors, or it will not find the complex patterns in the data. We've learned that, okay? And now here is a solution, cross validation technique, which will uh, help us to access the performance of the model unseen data. On unseen data, reduce the risk of overfitting. That's what it is going to help. K-fold cross validation divides data into k-folds. Okay, you can say the sections in kind of clusters, kind of groups. Okay, which is called k-folds. Okay, divides in data into k-folds and iterates through each fold for training, testing, and averaging the results for more robust evaluation. Okay, this is what it will apply the first principles here. It will split the big problem into small pieces and try to iterate and make the robust evaluation perform. It will give better results. Like if you want to climb Mount Everest, so you will say, oh, I'll go one day, I'll start, and one day I'll go just and climb it. No, you have to first go and climb small, small mountains, small range, medium range, high range, then go Mount Everest, right? You have to split the Mount Everest goal into small, small milestones, and then one year you go, and again you break into small small phases, and then you complete those phases, you climb the Mount Everest. Similar though, that's what is called first principles. So k-fold will cross validation divides data into k folds, small folds or groups or classes or something, and then iterates on them and gets training and testing done so that the averaging the result more robust evaluation. That is what it will do for a better performance. Because see, if you want to climb Mount Everest in 1 year, I would suggest you go 2 3 years climbing the other mountains and then you go for Mount Everest, because then your performance will be better. Then going in first year, you might not climb, you will have a lot of issues, physical, mental, and you will not be acclimatized and stuff. So that is, so I'm giving a bigger example you can relate. Same way, better performance, cross validation technique is a better performance model because it will help to optimize the evaluation and give more robust evaluation, and there will be a better performance. So let's see. Data split divides the data into k folds. This is what will first principles we do that. So Elon Musk applies first principles in all companies. That's why he's going to become a trillionaire. So that is why his performance is better than other people. Okay, he applies physics principles. Okay, and first principles mostly in all companies. Okay, if you see. Okay, then iterative training. Then again, a great concept of iterative training, because if you want to understand uncertainty, you have to be iterative. Train the model on K1 fold, test on the remaining folds. So you need to do iteration till you reach a optimal performance. Okay. That's why iterative training is required to get the best performance. Performance evaluation, averaging the performance metric across all k iterations like you have done. See, what k fold cross validation has done is it has created small k folds. Okay, then it is going to average that. So all k iterations for the reliable evaluation, it will average that, and that would be a better performance. Because if you attack a uh, big problem like without thinking, planning, and splitting into pieces, you're not going to win. You have to, when you plan and split that, execute, you have a strategy, you that's what this model does, guys. That's why machine learning, data science, AI, ML, deep learning are powerful. Because we human beings, we whenever we see problem, we start crying, or we start getting overwhelmed, or we start getting emotional. We don't split that into pieces and try to um achieve perform well on those pieces, and ultimately we have performed, our average is very great on the actual problem to like solve that particular problem. So same way, it will average the performance of metrics across all k iterations which k fold has done. Okay, for all reliable evaluation. So this is how the optimality of the performance is achieved with cross validation technique, and that's why it's a powerful technique. So let's move to the other section.
Yeah, sure, sir. So let's move on. Okay. Yeah. Choosing a right metrics. So we have seen lots of metrics, right? So in order to calculate the accuracy, like evaluate the model classification accuracy. Let's see how to choose the right metrics. Choosing a right evaluation metric for a specific problem is crucial. Consider the goal of the model, nature of the data, and the potential consequence of different errors when selecting a matrix. What are the consequences we will be getting? These things that you need to list it down before choosing a matrix. There is no one size fits all approach. There is no one size fits all approach. The best metric depends on the specific context and objective. Okay, as we are mentioning, right, everything is black box. You need to try with all kind of metrics, and you need to find which metrics works best for your data and for your model. Okay, that's it. Data characteristics, that was the first thing. Consider the distribution types and relationship within the data. That's the first thing that you need to consider whenever you need to choose the metrics. Model objective, identify a primary goal and desired outcome of the model. That is what next thing. You need to decide a model's outcome and then what is the primary goal. Error implications, evaluate the potential consequences of different types of errors for a specific problem. You need to consider three things: data, model, error, when you are choosing a right matrix. Okay, simple thing: data, model, error. Okay, these things you need to consider whenever you're choosing the metrics. Okay, so you guys can ask me, like, we are having multiple metrics. For accuracy we are having nearly 6 metrics, whereas for known 6 metrics, I will say. Whereas for regression we are having nearly 5 plus metrics, known 5 plus metrics, I will say. Okay, there are different metrics for calculating the evaluation of the model. So these are the three things that you need to keep in mind whenever you are just choosing the metrics to evaluate your model: what kind of data you are having, what kind of model you are using, and what are the errors that you will be getting. So yeah, this is how you can choose the right metrics. So yeah, that's it, guys. Yeah, yes, sir, over to you.
Yeah, so choosing the right metrics is very important, guys. It starts from the making the right problem statement, understanding problem statement properly, defining your objective function, and then collecting right data as per the objective function. Okay, then choosing, then doing the right pre-processing, EDA and all, and choosing the right matrix. Okay, choosing the, like, this is what it is, like choosing the data characteristics. It should be very clear. Okay, so for choosing the right metric, we have to do what, we have to choose the right evaluation metric. Specific problem is crucial, considering goal of the model. This is what I have explained. The nature of data. What is the nature of data? Is it according to the objective function, problem statement, the potential consequences, different errors when selecting the metric? There are no one size fit all approach. Like, it means that there is no, like, you need to understand each time. You have to put time, you need to have patience to understand data, problem statement, and choose according to that the right approach. There's no, like, you have chosen it for one project this way, you're going to again choose the same thing. No, you, every problem is different, you have to choose a different approach. That's what it means. You have to have different metrics, different approaches, different algorithms, different things to solve. Okay, the best metric depends on specific context and objectives. That's what objective function, what is the context, what is the characteristic of data. That would depend on the problem statement. What is problem statement holistically? And if you give enough time understanding problem statement and defining it properly, then and only you're going to collect right data with ethics and this. Then and only each thing will matter. So each step will depend on the previous step, guys. So, and then ultimately your performance of model will depend on all the steps you have taken before. So that's what it is. So each problem statement is different, unique. So you have to have a unique approach, finding the right fit for all the steps. Okay, so data character, consider the distribution, type, and relationship between the data. So that's what is data characteristics. That's what you have to see, or choosing the right metric. Okay, okay. Model objectives, identify primary goals, desired outcomes of the model. So model, you have to identify primary goal. What is the primary goal to solve? Suppose I'll give you example. You want to make next application with AI and future, like super intelligent, Zomato. You want to go, you want to become a competitor to Zomato. So you have to understand the primary goal, and then you have to enhance each feature which they are, and making it to a next level through AI, through data science, through different techniques and technologies and models. And you have to define the primary goal first. Always, whatever project you are doing, guys, focus on primary goal and then go for aesthetics and different aspects. First, make the primary goal happen. Once that objective is achieved, rest, enhancement, and aesthetics or shining or interior design will be done later. That can happen. But first thing is to achieve the primary goal of the project or the problem statement and desired outcomes of the model. Okay. Then error implications, evaluate the potential consequences of different types of errors of the specific problem. So understand the errors properly, and errors have solution. It's a game, errors, problems, and solution. You will see both. So it's a we have to play that game well, understanding the problem well, so that you develop a solution well. So once you understand, some people are they don't want to understand problems well and they want to create solutions. You're not going to create solution well. You need to understand problem like nobody else understands that problem. That is why you are data scientist, AI ML engineer, or AI researcher, or AI data engineer, or whatever, guys. That is what makes you unique. Whenever you dive into any problem, like the way you understand problem, nobody else understands. And then you will be able to create a solution and model which nobody else can, because you understood problem well. Okay, guys. So understand these concepts, because these are golden words with experience, and you will not hear anywhere these things, because they will not tell you these things. So go deeply, understand these concepts, and apply, absorb the information, digest and apply the information, define long-term objective function, have patience, perseverance, consistency, persistency, and build a long-term goal for your learning and continuously learn. That is the way to success. And go do all the quizzes, all the projects, whatever we have done, and keep learning deeply. Thanks.
Yeah, guys. So I hope like that's it. So we have looked into the for the past two session, last session and this session we have looked into the evaluation metrics in order to evaluate the classification and regression problem. Hope you guys have a proper understanding how to evaluate the model. So starting from how to evaluate the classification model, regression model, and different kinds of meaningful metrics as we have seen related to classification and regression. And finally, we have moved into how to choose a proper metrics for it. Okay. Hope you guys have enjoyed the session. Please make sure that you guys subscribe to our channel, because like every day we are posting a new video. So yeah, that's it, guys. That's it all about this today's session. So yeah, I hope you guys have enjoyed this session. We'll all meet in the next session. Until then, until next session, make sure you guys watch all our session and ready for the next session. So we will all meet in the next session, guys. Until then, take care. Bye, guys. We will all meet in the next session. Bye, guys. Take care.
Yes, guys, let's see you all in the next session. Keep learning deeply, and happy learning.